Good morning, everyone. This is Shiva from Soundbox Irrigation Design Services. So, we have discussed many topics regarding to the irrigation industry, the concepts and their products, and uh, how to approach the problems, maintenance. So, everything we have discussed about everything we discussed in this lecture session. So, today I'm going to discuss about some technical things, frictional loss in pipe. So, this we do not. Calculate this manually in gentle days because software itself calculates how much pressure needs to there at the valve. So which valve is critical valve and the critical pressure. So this everything is calculated in the software itself. So we are not calculating manually nowadays. So but the real concept, I just want you to expose the you to how to calculate manually and how the software works. So what's the concept behind that? So these are things I just want you to know that so that we can I want you to know so that we can use this uh, concept and effectively whenever we don't have software in our hand. So thank you for joining today. So as I say every time, if you have interest regarding any topic, please don't hesitate to ask me. So let's get into the topic. So first of all, what is frictional loss? We know that fluid has been flowing inside the pipeline. So some we know that whenever we are just bike is running on the road or bus is running on the road, there must be some friction between the tire and the road. So similarly, so there's also some friction between the flow and the pipe. So pipe is usually stationary. The fluid is flowing inside the pipe, which is in motion. So there must be some frictional between this. So due to that those hydraulic energy is converted to heat due to this roughness, due to this friction. There must be some heat presented between the stationary pipe wall and the fluid motion. So due to that pipe fluid may lose their pressure. This thermal energy cannot be converted to again hydraulic energy. So due to that the fluid drop may experience the drop in pressure. This conversion and loss of energy is known as head loss. We also call it friction loss. Head loss in the sense we calculate in terms of distance. So uh, I'm going to discuss a little bit in depth with an example in the upcoming slides. So just I wanted to start with the friction factor. So what is friction factor in this sense? For example, let's look at this picture. You know that this is valve and this is the farthest head, which means the lost head comparing to in terms of comparing to other heads. This is the head which is long away from the ball. So we know that this head is more away from the more away compared to the other heads. So it needs the more piping, it needs longest distance to come connecting to the ball. So we are just taking this as the farthest head. So we know that the operating pressure of sprinkler heads is around 30 psi. So due to this is we need to maintain 30 psi at this head. But what if it is what's the pressure at the initial head of the particular zone? So you know that there must be some pressure difference. For example, if this is 30 psi, so obviously this pressure head may experience the higher pressure comparing to the for this case. For example, it may receive 35 psi because some psi may have lost due to the frictional frictional loss. Some pressure may drop due to the frictional loss. So but the ultimate thumb rule is we need to maintain 30 psi at least in this farthest hit. But this head may receive the this head may receive the excess psi. So we need to maintain this at least only within the 10 to 20% difference between these two heads. Otherwise the uniformity of the pressure head may vary. For example, if it is operated at the 35 psi, it may receive the it may give us the 2.3 gpm of water. But what's the scenario here? It only gives us the 2 gpm at that pressure, at the 30 psi pressure. But this head may gives us 30 3 2.3 gpm of psi at the 35 psi. So we need to maintain the uniformity so that the pressure difference must not be greater than difference must not be differ than the 10 to 20 psi pressure. So we need to keep that in mind. So that's why we are going to just measure the difference. We're just going to limit the pressure difference. So this is P. What's the friction factor? How to calculate this? This is PO. PO is the operating pressure of the sprinkler. So PV is the pressure variations allowed between the valve and the last sprinkler, and LC is the length of the pipe from the farthest head to the valve. So the thing is, we know that operating pressure of the sprinkler head is 30 psi, and PV it must not be more than the okay, let's assume 0.1 here, which means 10%. The pressure difference must not be more than the 10% from the valve to the last farthest head. So we are just taking this V as the 0.1 or 0.2. Sometimes you may take 0.2, but I'm just limiting the pressure difference. So I'm just going to take 10%, which is 0.1. So length is, we know, control to the farthest head in hundreds of feet. So if I'm just, I have shown you the picture earlier. So I'm just giving you with the distances how to calculate this. So we know that from the valve to the farthest head is, so 20 plus 80 plus 40 plus 60 is equal to 200. So 200 is length of the valve from the farthest head. So PO is 30 psi, PV is 0.1. So I just giving you the applying the every formula. So 1.5 allowable psi loss per 100 feet of pipe. So if you take this is 200 feet. So I'm just only making the pressure difference should be within the 1.5 psi allowable pressure psi per 100 feet of pipe. So you cannot lose more psi than this 100 feet of pipe. So this is how I just wanted to discuss with you uh, how to calculate the friction factor. And so we may not be able to calculate every time whenever we are so that's we have computed the table itself before. For example, friction factor. So this is I'm just giving you the different classes of pipe with the different diameters. So how much pressure how much flow it can be go within these particular sizes. So for example, if the flow required at the particular section is 10.8 gpm, so we can go up to 1 inch PVC pipe, class 200 PVC pipe. uh, if it is 19.9 for gpm is up to 19.9, so we can go with 1.25 diameter of pipe. So first determine the quantity. For example, I'm giving you this picture. So this is the valve, so this is the sprinkler heads. We know that each sprinkler head is operating at 2 gpm. Next one is, so at that point the pipe needs to give the 4 gpm. At this point pipe needs to give 6 gpm. At this point you have to calculate whole, so it needs to give, it needs to give 10 gpm. So at the initial it needs to give 14 gpm. So you need to keep that in mind. If it is, if this section needs to supply 14 gpm gallon per minute, so how much, what should be the appropriate size for the this particular section? So 14 dBm falls between 1 to 1 and of 1.25 inch diameter. So obviously we need to go with 1.4 inch, 1.25 inch, which means 1 in 1 by 4. This we need to size the pipe length within this range. So I have sized this as a 1.25 inches, and this is, and this section needs to give 12 gpm. So which means 12 gpm is also falls under between the 1 inch and 1.25 inch, so we need to give that 1.25 inch. Similarly, for this section this is 10, for this section this is 6, for this section 4, this section 2. We need to size according to the tables which have calculated before itself for the different pipe sizes. We need to use that. So this will be very handy whenever we are using this, uh, whenever we are calculating the frictional loss in field. So we may not have a, laptop or a system with us to calculate uh, with the help of software. So we need to calculate it manually at that time. So it will be very handy. These tables will be very handy for us. So many websites has provided this. In Steinberg Hunter has provided this table chart for different pipes for different sizes. So how they are calculating this formula? So we know that we are limiting the some kind of like velocity should be within the 5 feet per second, so that the velocity so that the pressure lot will not be very higher. So we need to so how to calculate this? So the concept behind the uh, calculation of friction loss is the Darcy Weisbach formula. This is F into L V squared by d 2t. The F is the friction factor. We have calculated how to calculate this. S is the length of the pipe. D is the inner diameter of the pipe. V is the velocity of the liquid. This is the gravitational. So H is the frictional loss. So this must be calculated with using this formula. So if you have any doubts regarding this any topic, please don't hesitate to call me. If you have any other regarding to any other topics, please always I'm eager to help you people. So as of now, thank you for joining today.